3.3 More on functions. In this section, we are going to learn how to determine whether a function is even, odd, or neither. Identify the open interval on which your function is increasing, decreasing, or constant. Identify the local maximum and local minimum on the graph. Even functions, f of negative x is equal to f of x. So that means the negative x-axis is equal to positive x-axis. They have the same y value. For all x in the domain of f, the graph of the function, we call it symmetric about the y-axis. The function is called an even function. So when the graph is symmetric on the y-axis, we call it an even function. For example, you have the parent function of the parabola, it passing to 0, 0. This graph is symmetric about the y-axis, so this is even function. When you have the facing down parabola, even though it doesn't pass into 0, 0, but this graph still counts for even function because the left-hand side half is equal to the right-hand side half. It's a symmetry on the y, so this is the even function as well. Absolute value function, the graph is symmetric on y as well because the left-hand side part is equivalent to the right-hand side. So this is the even function. Down V shape, this is a negative absolute value function is respect to the y-axis as well. So this is even function. This graph, the parabola facing is a parabola, is power 2 function. However, the vertex point, this graph has shifted to the right, for example, 1, 2, 3. So the vertex point has shifted from 0, 0 to the 3, 1. If you look at this graph, the graph doesn't symmetry on the y-axis. So even though this is a power 2 function, we don't count this as an even function. So this one go with neither. Odd function. The odd function has negative x value, which this is y, will equal the negative y. So the negative x and the positive x, they have the opposite y value. We call this is odd function. In other words, they are respect to the origin or symmetric about the origin. For example, rational function or reciprocal function. These two parts of the curve is symmetric about the origin, right? So based on the origin point, this curve is equivalent to the other curve or identical to the other half of the curve based on the origin. So we call this is odd function. Power 3 function is symmetric about the origin as well. This part is identical to the other part, and they are respect to the origin. This is a cubic root function. So same way, this part is identical to the other part, and they are respect to the origin. So all the graph here, they are the odd function. This is odd as well. So when the graph doesn't match symmetry about the y or doesn't match symmetry about the origin, in that case, they go with a neither. So if you look at example, this one, x power 2 plus 1. So that means this is parabola, facing a parabola, shift 1 unit on the y-axis. So the parabola facing up. Although it didn't pass into 0, 0, that is okay. It still counts for the even function because they are symmetric about the y-axis. So this is the even function. Power 3, we just discussed this one earlier, so this is odd function. Additionally, it's not really necessary you plug in the negative x or positive x, those things, to see whether both sides of the equation they are equal or not. I think the easier way is just sketch the graph and look at the graph to determine whether they are even, odd, or neither. If we trace the graph of a function from left to right, keep in mind this order does matter. You have to trace the graph from the left to the right. Always. When you determine the increasing, decreasing, or constant interval. The value f of x increases as shown in the figure. We say that the function is increasing on the interval a, b. So from a up to b on x-axis, if you look at the curve of the graph, it's going up, right? There's no going down interval. So from a to the b, they are all increasing. And keep in mind, we always from the left and then toward to the right. If you look at this graph, from A to the B, A is here, B is here. So if we start from A, the graph is going down until the B. So from A, B, graph here, from A to the B, during this interval, they are decreasing interval. If the graph f of x remain unchanged as x increases, we say the function is constant on the interval a, b. So from a, b, from the left to the right, it didn't go up, it didn't go down, it just stayed flat. So this one would be constant. Now state the open interval on which function is increasing or decreasing. Keep in mind, we always trace the graph from the left. Alright, so you have to point your graph from left hand side to begin with. So start from the left hand side, it's shown it's going up until they hit the x equal -2. After x equal -2, the graph changed the direction, turned to going down until the graph hit the x equals 0. We look at the x-axis. Keep in mind, when you determine the decreasing, increasing interval, we are targeting the x value, not a y. So once the graph hit the x equals 0, it changed the direction, turned to the going up. And then when the graph hit the x equals 2, it changed the direction again. So the way we represent the increasing and the decreasing interval. One more thing is when you record your increasing or decreasing interval, always go with the parentheses. There is no bracket. So parentheses all the way when you perform your decreasing, increasing. So start from the most left-hand side, the increasing interval would be -infinity, right? Because it will keep going down forever on the negative x-axis. So increasing interval is from -infinity up to -2. And then another increasing interval is from 0 up to 2. So use another one, 0, 2. So this will be the increasing interval. For the decreasing interval, it's from -2 up to 0. So record -2, 0. And then after 2, it will keep going down forever. So this arrow tells us going down forever on the positive x-axis. So it will be 2, infinity. So this is the way you record the increasing or decreasing interval. Okay, I forgot to put a union here. So put the union. Okay. Finding the local minimum or local maximum. If you look at the graph here, this would be the local maximum. When you determine the local mean or local max, we are looking for the y value. So this would be the local mean. So you need to look at your y. So what it is, or this point, what it is. That would be the local mean or local max. A local maximum occurs when the function changes from increasing to decreasing. So when the function changes from increasing to decreasing, it will have a local max occur. When the graph changes from decreasing to the increasing, it will have a local minimum occur. Okay, so now the last slide here, I'm going to show you this graph. How can we determine the increasing, decreasing, or constant interval? So again, we start from the left hand side of the graph. So it's going up until the graph hit the x equals 0. It changed the direction to go down, going down, going down. So when you represent the increasing interval, we use the negative infinity up to 0. Keep in mind, only come with a parenthesis when you represent the increasing, decreasing. For the decreasing interval is from 0 up to 1, 2, 3. So x equals 3. So write down 0, 3. Close it. Constant. The constant interval is here. And it has shown there's an arrow on it. That means it will go to forever of x-axis. So your constant interval is from 3 up to infinity. So put the 3, infinity. Keep in mind, they'll come with the open parenthesis. There is no bracket. When you use a bracket, only deal with the domain and the range, not the increasing, decreasing interval. Now you can move on to work on your web assignment.